The recent confirmation by NASA and the International Astronomical Union that the mysterious object previously known as A11PL3Z is actually an interstellar visitor has sparked intense curiosity and excitement within the global scientific community. Now officially designated 3I/Atlas, this cosmic body represents only the third confirmed interstellar object ever detected passing through our solar system. The rarity of such an event cannot be overstated. Humanity has only observed two other objects of this type, the oddly shaped Oumuamua in 2017 and Comet 2I/Borisov in 2019. Each of these earlier discoveries challenge astronomers to rethink long-held assumptions about how objects travel between star systems, and 3I/Atlas promises to do the same. The object was first noticed in late June when the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, captured unusual data through its telescope stationed in Hawaii, Chile, and South Africa. These automated instruments scan the skies nightly for fast-moving objects, and the data from June 25th to June 29th drew immediate attention due to its highly unusual trajectory. As soon as astronomers realized this object was traveling in an extremely straight, flat path, a hallmark of bodies not bound by the sun's gravity, speculation grew that it came from beyond our solar system. Subsequent examination of earlier telescope data revealed that the object had actually been detected as far back as June 14th, giving researchers even more time to analyze its motion. One of the most remarkable aspects of 3I/Atlas is its extraordinary speed. NASA estimates that the object is moving at roughly 152,000 miles per hour, or about 245,000 kilometers per hour, far faster than typical comets or asteroids native to our solar system. This incredible velocity, combined with its nearly linear course, strongly suggests that it entered the solar system from interstellar space and will exit just as swiftly, barely influenced by the sun's gravitational pull. Objects formed within our system typically follow elliptical orbits shaped by the sun's dominant gravity. But interstellar bodies behave more like cosmic tourists, briefly visiting before flying back out into the vast darkness of space. Initially, experts thought the object might be a rocky asteroid, much like early interpretations of Oumuamua. But new observations released by NASA and the IAU reveal that 3I/Atlas exhibits traits far more consistent with a comet. The presence of a coma, a glowing envelope of dust and vaporized ice surrounding the nucleus, indicates that the object is warming as it approaches the sun and releasing material into space. Some telescopes have even detected what could be the beginnings of a tail, formed as solar radiation pushes dust and gas outward. These characteristics strongly suggest that 3I/Atlas is not a barren rock, but a body rich in ice, similar to Comet 2I/Borisov, which displayed clear cometary activity during its visit in 2019. However, because the object is still extremely distant, scientists caution that more data is needed before they can determine the full extent of its behavior. Much about the physical characteristics of 3I/Atlas remains unknown. The object is too far away and too faint for precise size measurements, but early estimates suggest it may span up to 12 miles, or about 20 kilometers, across. This would make it significantly larger than Oumuamua and comparable in scale to some of the larger comets that inhabit our outer solar system. Its shape, composition, and surface features remain a mystery for now. The challenge of observing an object that is both exceptionally fast and fleeting makes every telescope measurement critically important. As it continues its journey toward the inner solar system, scientists hope improved imaging and spectroscopy will reveal more clues about the materials it contains, potentially offering insight into the chemical makeup of other planetary systems far beyond our own. Currently, 3I/Atlas sits at a distance roughly 4.5 times farther from the Sun than Earth is, placing it beyond the orbit of Mars. Despite its great distance, astronomers are tracking it carefully as it brightens and becomes easier to observe. Its closest approach to the Sun, known as perihelion, is expected to occur on October 30th. At that time, it will come within approximately 1 for astronomical units of the Sun, just a bit farther out than the orbit of Mars. Shortly before reaching this point, the object will also make its closest pass near Mars itself, approaching within 0, for astronomical units, of the red planet. Although this is still a vast distance by human standards, the proximity offers an excellent observational opportunity, especially for spacecraft or telescopes operating in Mars' vicinity. The confirmation of 3I/Atlas as an interstellar object represents far more than just a new astronomical milestone. For scientists, it offers a rare opportunity to study material that originated beyond our solar system, fragments formed around an entirely different star. Each interstellar object carries a unique chemical signature that reflects the environment in which it formed. These cosmic visitors act like messengers from distant regions of the galaxy, carrying clues about planetary systems we may never otherwise observe directly. Understanding their composition allows researchers to compare our own solar system to others and refine theories about how stars and planets take shape. For example, the peculiar acceleration of Oumuamua sparked debates about exotic materials or unusual outgassing mechanisms, while the dust properties of 2I/Borisov revealed that its home system contained familiar ingredients like carbon monoxide and water ice. Because only 2 interstellar visitors have been observed before, astronomers have long suspected there must be many more passing through unnoticed. The vastness of space, combined with the small size and faintness of these objects, makes them incredibly difficult to detect. As telescope technology improves and sky scanning systems become more sensitive, discoveries like 3I/Atlas may become more common. Its detection by ATLAS, a system designed primarily for spotting potentially dangerous near-Earth objects, demonstrates how automated survey networks are becoming essential tools for identifying such rare events. The hope is that continued improvements to these systems will eventually reveal a steady stream of interstellar travelers, allowing scientists to build a more complete picture of our galactic neighborhood. For now, astronomers are focused on gathering as much information as possible before 3I/Atlas leaves the solar system forever. The object will likely grow brighter as it nears the Sun, although its exact behavior remains unpredictable. Comets composed of fragile material sometimes break apart under solar heating, and the same could happen here if the object contains volatile ices that vaporize rapidly. On the other hand, it may remain intact and develop a long, spectacular tail visible through powerful telescopes. Either outcome will provide useful clues about its structure and origins. The path of 3I/Atlas through the solar system will offer multiple observation windows for both professional astronomers and advanced telescope facilities. Space-based instruments like the James Webb Space Telescope and the Hubble Space Telescope may attempt to capture detailed readings of the object's composition. Ground-based observatories could map changes in its brightness, allowing scientists to infer its rotation, surface features, or potential fragmentation. Even amateur astronomers may try to track it as it grows brighter, contributing valuable data points to the global effort. Perhaps the most intriguing aspect of interstellar objects is the possibility that they represent material from places not just far away, but fundamentally different from our own. If 3I/Atlas contains unusual isotopes, rare minerals, or unexpected chemical ratios, it would provide direct evidence that planetary formation processes elsewhere in the galaxy follow paths distinct from those in our solar system. Conversely, if its composition matches the comets we are familiar with, it would strengthen the theory that planetary systems throughout the universe share common building blocks. Either way, the discovery enriches our understanding of cosmic evolution and deepens the scientific narrative of how matter travels through interstellar space. As 3I/Atlas approaches the later months of the year, public interest is likely to grow, especially among those fascinated by the mysteries of space. While the object poses no threat to Earth, its passage offers a dramatic reminder that the solar system is not an isolated bubble, but part of a much larger galactic environment filled with wandering debris, ancient fragments, and cosmic travelers crossing unimaginable distances. Moments like these encourage humanity to look outward, to contemplate the immense scale of the universe, and to appreciate how much remains undiscovered. The story of 3I/Atlas is still unfolding, and scientists expect to learn much more as additional observations come in. For now, its discovery stands as a powerful demonstration of modern astronomy's ability to detect and analyze extraordinarily rare celestial visitors. In the coming months, the world will watch as this icy traveler from the depths of interstellar space sweeps past our sun and continues its silent journey back into the darkness, carrying with it secrets from a distant home that we may never see, but can begin to understand through the brief, precious encounter it offers.